Okay, we're going to use this video to just highlight how to read particular types of angles. There's three main categories that this is going to fall into. We have positive and negative angle, positive and negative magnitude, and then we have angles not measured from zero. We'll talk about, I don't need that. We'll talk about a fourth category of these, but really it's just going to be a combination of the three that we already mentioned. So, whenever you see an angle listed, the first thing you need to note is the positive or negative and what that particularly means. Let's begin with how angles are typically going to be listed. This right here is the zero. Why? Because somebody at some point in time decided that that was the zero and they just picked it, and everybody else stuck with that as the standard. So if you see an angle, such like 10 meters at 40 degrees, and you see absolutely nothing behind it, it is assumed that it's measured from the zero. Of course, since you don't see anything in front, that means it's positive, and obviously since you don't see anything in front over here, we'll start with the typical way you see things. Of course, since you don't see anything over here, it's measured from zero. The positive on the angle means that it's measured in a, I'm not going to do this well. Let's try this again. Close enough. The positive here means that's going to be measured counterclockwise, so positive angle here means counterclockwise. This writing is terrible. Counterclockwise. And the fact that it's positive here means that it stays right here, or we've decided that this angle is the positive direction. Okay? So let's counter each one of those now. What if it were a negative angle? Well, as we said a moment ago, the positive angle means that it's gone counterclockwise. So if you were to see the exact same thing again, the only difference being negative angle, there's nothing after it. The only difference is you're going to go clockwise this time. So since you see nothing after, you still start at zero. Since you see the negative, we know to go counterclockwise now. And since you don't see anything on the magnitude, again we know that whichever angle this is going to be the positive direction. And so it's going to stay right there. So that's the difference between positive and negative angle. Just which direction you go from the center. Now let's handle positive and negative magnitude. Again, I'm going to start with the original that we used here, 10 meters at positive 40 degrees. Instead, let's change this to negative 10 meters at a positive 40 degrees. Nothing afterwards. Okay? This time, again, we see nothing here, so we measure from the zero. You see a positive 40, so that you know to go up 40. Except then you see the negative, meaning that this 40 degrees is our positive still, as it was set here, but this wants us to go the exact opposite way of what's set here. Now you can do this in a couple ways. You can of course see that it's that way and just draw it down the opposite way. Or what you can do is you can actually change this vector so that it reads in a positive value. And the way you do that is negative 10 at 40 degrees is the exact opposite direction of 40 degrees. The way to make something go the exact opposite direction is just to add or subtract 180 degrees. So this vector here will be the same as 10 meters at, add 180 degrees to that, 220 degrees with nothing after, assuming measured from zero. So let's 220, apologies, that's not 222. So that means I'm going to go 90, 180 plus another 40 to get my vector where it actually belongs over here. Now in terms of graphical vector addition, all this is going to mean is that you need to reestablish what the actual value is at the beginning, and then you can use this number rather than this one to do your graphical addition. In terms of components, if you need to use that, you really don't need to change anything at all. You can actually use the negative 10, 40 degrees, and the negative will switch things for you. Let's look at the last one now. Not measured from zero. You can see that all of these have been blank so far because it means that we've been going from right here. And for vector addition, that's typically the way you're going to see it, but it's not always the easiest way to measure something. So let's again start with our original vector here, 10 meters at 40 degrees. But this time, rather than put a blank, let's write from the positive y-axis. Typically the 0 is the positive x-axis right over here. So what that tells us this time is rather than measure from our 0 as we have been the entire time, we're instead going to start from right here. Since it's a positive value, again we know to go counterclockwise, and I'm going to go 40 degrees counterclockwise. That's going to put my angle right there. Now you could rewrite this as well. Because I'm measuring from the y-axis, I can see that I have 90 degrees to the 0. So if I prefer to rewrite this in its original form, right up here, this vector is going to be 10 meters at, this is 40, plus the 90 that results from that, means that this total is going to be 10 meters at 130 degrees from the original 0. So these are the three different ways to look at how to measure angle. The final thing that you're going to see is a north, south, east, west type configuration, which is not as often. We don't see that nearly as often. It's going to happen, but it's basically going to do exactly this. So for example, in that situation, you're going to see something like this. It might say 10 meters at 40 degrees. Let's go north of west. The of west is exactly like this blank right here, telling us where to measure from. The west, of course, being over here, tells me to start measuring right from that axis right there. North serves the purpose of my positive and negative angle here, telling me in what direction to measure that angle. So the north tells me to go this direction, 40 degrees, and so I know that that angle is 40. And then my 10 meters here is the length of this line. So that's going to be how you measure angle in this chapter.